We've had some tech issues. I'm missing a piece of something required to make stuff go. We may have some glitches. Right now, I can't use my tripod because the part that I need to put my camera on my tripod is missing. So right now, my camera is sitting on a garbage can, which is why the camera angles are weird. So please just bear with any headaches. We have a science question in Twitch chat. Henshi asks, if Andromeda is like 200,000 light years across, why does it look so round and not oblong and distorted? It does look elliptical in detailed pictures of it. So Henshi is asking about the Andromeda galaxy, which can conjure an image of. So I'm going to push a button here. Could Twitch people confirm for me that you still have audio? We had some issues with audio when I did this before. Yeah, good, good. So Andromeda Galaxy is this beautiful thing. And Henshi asks, why is it round and not oblong and distorted? So here's kind of a funny thing. Henshi, when did you see this looking round? Because it turns out if you're looking through, looking at this with your eyes alone, you'll often just see the bright part at the center, which is roundish and fuzzy. And with a larger telescope that gathers more light, you can see a picture like this. Sultan, I will address that in the questions bit later. So we had a science question right at the beginning. So let's get started. We'll come back to those two quotes. So a couple of announcements. Oh, and I have to push the button. That makes me bigger. Boop. There we go. So your second project is due before class on Thursday. Tonight or Wednesday morning, or sometime Wednesday, I will post the list of who is reviewing whose work, so you know who to email. If you're a little bit late, don't sweat it. As I said earlier, before we started formally, stuff's been a bit rocky for me in the last 24 hours, but so like stuff happens. You know, I'm running a little bit behind today, and if you all are ever running a little bit behind, I've gotten some email from people saying, we have an exam. I'm like in some other class. I was a little bit late turning something in. Don't worry. We are not super tense about deadlines in this class. Everybody's got a lot going on. Life is really crazy for everyone right now. You know, anybody following the news, it's kind of one horrible thing after another. Friday night, there were a lot of folks on the staff Slack channel for this class kind of really having some real talk about the state of the world based on the news that we all got on Friday with the passing of Ruth Bader Ginsburg. So, you know, if you all are concerned with a lot of things other than this class, that's okay. I want you to be concerned with a lot of things other than this class. And if those concerns, whatever they are, mean that, you know, you have to go to lab later in the week, or if you didn't finish your lab during the lab period and it takes you 3 more days rather than the 2 we asked for to do it, don't sweat it. We are going to be very relaxed with things like this. We want you to be adults. We want you to try to get your work done by the due dates. But if once in a while you don't, that's okay. Make sure, now, if that happens, respond to that like adults. Remember, another group is going to be expecting you to send them your work. So send them a note and say, hey, we'll get it to you 24 hours late. It's coming, don't worry. Do them that courtesy, and they will do you the courtesy of saying, no worries, it happens. Oops, I didn't mean to fade myself out, I clicked in the wrong place. There we are. For the paper, this is what Sultan is asking. Your first draft of your first paper is due next Monday. You'll send it to somebody else, we'll give you feedback, we'll tell you who that is. They'll give you their feedback in a few days, and then you'll have a few more days to submit a final draft. So your paper, the final draft, is due not next Monday, but the Monday after. There is potential for significant extra credit. So make sure you, if that's something you're interested in, be creative, do the best job you can. If you have, make sure you read the entire document, because there are some special assignments for particular choices. Yeah, midnight on Monday. LMCG asks in Twitch chat. Are there any questions about the papers? You can, if you have a draft that you'd like your TA or me to read, you can send it to us. You can also share it with other people in your groups. Your group mates, the people you've been working with this whole time, they're writing papers about the same topics, right? So Maggie, if you're in a group with Sultan and you want them to look at your paper and say, hey, could you give me some feedback on this? Go for it. Where can you find the prompt? So if you go to the course website, which is at the same place it always has been, there is a link here that says Paper 1 at the top. And you can read here. Scarlett in Twitch chat asks, do you need to get your topic approved? No, you don't. Now, if you have something that you think is very oddball, feel free to ask us about it. So, for instance, the student last year who wanted to write about timekeeping in Minecraft said, this is kind of peculiar, I want to talk to Freeman and see if it's a good idea. And my response was, that's awesome. But if you have an off-the-wall topic that you want to discuss, then please discuss it with us. But no, in general, you don't need to get your topic approved. Annie says it's the first time hearing about the paper. Yeah, we assigned it last week. It is on a connection between motion in the sky and ways that people keep time. So a calendar. We want you to pick an ancient, historical, or modern, or fictional calendar, way to keep time, and discuss its relation to the motions of astronomical things. There are, there are a couple of calendars where we want you to do something different. So if you pick, say, the Jewish calendar or the Chinese calendar, there are particular assignments for that. If you choose the Islamic calendar, there is a particular assignment for that. If you choose the ancient Egyptian calendar, there is a particular assignment for that. Some of the more popular fictional ones are Lord of the Rings, Game of Thrones. There are suggestions for those. So I'll let you read all of this. I'd also encourage you to read the section here about the use of Wikipedia. The short version is that I am very pro-Wikipedia. I think Wikipedia is possibly the best thing that humans have done in the last 15 years. So I encourage you to use Wikipedia as a jumping off point for your own research, and I have some advice on how to use Wikipedia on the webpage. Can you do Adventure Time? I am not familiar with Adventure Time, but you can tell me what that is. Henshi, if you can come up with a cosmology, they refer to Jimmy Buffett's song where it's always 5 p.m. If you can come up with a cosmology where it's always 5 p.m. and find some sort of... I'm not joking here. Like, if you can look at Jimmy Buffett's other songs, and I'm not a Jimmy Buffett fan, and come up with, like, some abstract cosmology where it's always 5 p.m. and that makes sense, that would actually be a super awesome paper. Remember, we got a great one on Peter Pan that was kind of that kind of stuff. So, Henshi, I know you're being silly, but Monty Python is great literature, right? It's fine. So that's the paper. Anything else anybody wants to talk about the papers? And if you see me looking back and forth, I have Zoom chat here and Twitch chat there. Is it possible to see some of the fictional papers from before? I could probably dig out some of them. So Joseph, send me a note, remind me of that, and I'll like fish through the previous ones and pull out one. There was, I remember one from last year or before where somebody took a look at all of the popular fan theories about what's going on in Westeros in Game of Thrones and said, none of these make sense. That none of the fan theories of timekeeping in Westeros actually make geological and astronomical sense, and it was a really good paper. Aryan, yes, you can write about Interstellar. There's no particular word number requirement. We'd like you to write at least a single-spaced page. But really, we want you to write enough that you say interesting things, but not so much that you run out of interesting things to say. Porpoise in Twitch chat points out that maybe Jimmy Buffett lives on one of those worlds in Lab 2B. Other questions about the paper? Give you all 15 seconds to type more about those. Tyler asks, does it have to be an American Psychological Association or Modern Language Association citation style? The only thing I know about MLA and APA citation style is what they stand for. I don't know the differences between those. I know when I write a paper, I have a LaTeX template that does whatever I need to do for the physical review, which is the journal I publish in. You can cite your sources in any clear style you're familiar with. You need to cite your sources. You need to tell me what you read, but I don't care how you do it. Dorothy, absolutely. There was, we tried to recruit her as a coach. There was somebody who wrote a great paper about the Druidic timekeeping, the people who built Stonehenge. So yeah, Stonehenge is a great topic. I still remember sitting in our little kitchen up there talking to her about her paper, which was really good. And I'll note that please be creative, right? You know, if you want to write about Margaritaville and you can come up with something cool to say, then go for it. But if you have an oddball topic, it's probably going to be a cool one. Another thing I need to say is that I have been kind of negligent in having consistent discussion hours. Part of that is because of some other craziness happening in my life, which has now settled down. So I can now predict when I can have discussion hours. Here are the times. During those times, I will be sitting on the steps of Hendricks Chapel. I will also be on Zoom. I'm going to have headphones with me so I can talk on Zoom. I will also have me with me so I can talk in person. These are the times when I can come chat with anybody. If these times do not work for you, if somebody said, sad face, I have class, let me know. I will set up some other time that I can meet with you. D. Goldberg in Twitch chat asks if they can write about Star Wars. Absolutely. There have been some really good papers about timekeeping in Star Wars. So I'll leave this up just a moment more for people to write down the times. I will also send that out to everybody as a note. Anything else anybody wants to talk about before we move on to the sky? The first draft of your paper is due next Monday. You will send it to someone else who will give you feedback. Yep. Yes, so Yuri asks, during discussion hours, can you get feedback from me? Certainly. And if you want to send me a draft, I'd be happy to look at it. Now, I may get buried. If I get like 300 drafts, I won't be able to look at them all. But if you ever want to come find me during my discussion hours and say, here's my draft, I would be happy to read drafts for people. Yeah, Ryan, you can send it to me. Send it to SU Astronomy 101, because that way everyone can look at it. And I'll tell all of the TAs to look at that address and give people feedback. The Zista asks, are grades posted anywhere for this class? We've just started to grade things. It takes TAs about a week to grade stuff, so we're doing, this is week 3. Week 1 lab was graded during week 2 and is just now getting done. They're not on Blackboard. I'm going to start transferring grades from our spreadsheet over to Blackboard, so you'll start being able to see those. We'll get your grades on Blackboard, as we're able. Michael, if you have an idea of artificial stuff like Stellarium, if you want to write about how Stellarium does the magic it does, that would be a really cool paper too. So yeah, you can bend the topic. That's great. So I want to move on to the main topic for today. So we're now beginning the second unit of our class. We have now figured out how to predict how the things in the night sky move. We know how the stars move. They just rotate around the celestial sphere. We know how the sun moves. It also rotates once per day, but it is lined up slightly different with the stars every day. We now know that this is because the Earth moves around the sun, but the ancients did not know that. And we'll talk about that a little later. We know how the moon moves, but we don't understand the planets. Now, last time, a couple of people, I believe in both Twitch and Zoom chat, said that we know the motions of the planets are because both Earth and, say, Mars move around the sun, and their combined motion produces the retrograde motion that we see. But just from looking at the night sky, we can't figure that out. And what we're going to talk about in Unit 2 is how people figured out that the sun was at the center of the solar system and in the process invented science. Remember, this class, I want to kind of indulge me, please, for perhaps a 5-minute digression. I want to speak for maybe 5 minutes about why we've made some of the choices we've made. Our world has gotten sort of pessimistic in the last several years. There have been a lot of depressing things and pessimistic things in our world saying that we are not really able, as a species, to do better. And we've seen a lot of stuff happen that is not all that optimistic. And I have hoped that this class, for me and for students, can be something of a rebuttal to that. Because in my education as a scientist, when I was in school, I remember being floored at learning about all of the things that, the ways that human society has advanced. My grandfather was born in 1917. He grew up on a farm in Illinois. And when he was an old man, he would speak about this magic thing that happened in his little farmhouse in Illinois. They got a little motor, a little kerosene, I think it ran on, motor, connected to a generator that would charge up a battery. And then that battery would power one little light bulb. They had electricity, this magic thing, in like 1922. When he was a boy at his farm in Illinois. They didn't have power lines, right? There was no power out there, no power lines. But they had this little generator, and they could make their one little light bulb go. And he told me that story in 2017, when he was 100 years old, sitting at the dinner table with his iPhone in front of him. I mean, imagine a man who lived from one little light bulb on his farm to an iPhone, able to access the sum total of human knowledge on Wikipedia in like 15 seconds. Like, that's an amazing life for one man. When he was a boy, his parents lived in terror of polio, this disease that disabled so many people, including Franklin Delano Roosevelt, the United States president who helped win World War II. Now, polio is almost eradicated. Right? We see all of these things, and these things have happened because of hard work, because of attention to ethics, but also because of the scientific method. And I have hoped in this class to kind of set in counterpoint the things we are capable of and the pessimism of the world today, and to kind of argue that science is a route to doing better, to an antidote to the pessimism that we see around us. And the rest of our class, we've now looked at what you can learn from just the night sky. But the rest of our class is going to be the story from the beginning of science up to dreaming of flying to the stars. That's what we're going to do. And we're now starting that in the very beginning. So that's the plan for the rest of the class. In Unit 2, we're going to invent science. We're going to see how trying to answer this question about what's at the center of the solar system led to the birth of the scientific method. In Unit 3, we're going to look at light, and we're going to learn how the colors of the sun and the stars teach us that we are made of stardust, and that the atoms in our bodies are the same as the atoms on the other side of the universe. This really profound statement about our place in the cosmos comes from looking at little rainbows, right? That's Unit 3. And then Unit 4 is how do we get there? One of our coaches, who I think is here right now, Quincy Gray, I remember she would sit in the third row, I believe, or maybe the fourth row, chanting, "I want to go to space, I want to go to space, I want to go to space," during class. Kind of whimsically, but she's right? And that's how we're going to end, is talking about going to space. Hi, Quincy! She just commented in Twitch chat. She's the one with the little sword. She's a moderator. So I hope that you all will join me in this story from now until the end of class. I think it's the greatest story ever told of how we came to find our place in the stars. And this story doesn't just begin in one spot. It began everywhere on Earth because the night sky is everyone's heritage. Everybody looked at the stars. They all figured out stuff in their own way. People a long time ago were just as clever as people are now. Here's some examples of that. The 1066 here, by the way, is wrong. This is actually 1051. I typed in the wrong number. I had a brain fart when I made this slide. There's a supernova in 1051. I believe it is the brightest supernova seen from Earth in memory. And Chinese astronomers saw it and kept like these super good records of what was going on. And much of what we know about that supernova and the remnant, the Crab Nebula that it left behind, is because of the super good timekeeping and the very informed ways that Chinese astronomers documented the night sky. I talked before about this amazing thing that the Australian Aboriginals somehow knew, that a certain star is a pulsating red giant. I don't know which one it is, I'm sorry. But that was transmitted through oral tradition and mythology rather than through technical records, simply because that's how Aboriginal culture operated. We know that Pacific Islanders were very, very good at celestial navigation simply because they are in Hawaii. You can't get there, you can't find your way over the vast spaces of the Pacific without understanding the night sky really, really well. And we'd be here for years if we looked at them all, and I don't know everything about every culture's engagement with the night sky. If you are interested in these topics, if you are interested in how some culture that you are fond of or that you have a connection to engaged with the night sky, there's an opportunity for you to write about this in your final project. Yeah, Henshi, I had the date of the Battle of Hastings stuck in my head. Exactly. You figured out what it is. But instead, we're going to tell the story that led to the emergence of the scientific method. And that narrative will take us from Egypt to the Islamic world to Renaissance Europe. We've kind of, in our class so far, we've been a little bit cavalier about stirring together two different ways of understanding the sky. One of them is the celestial sphere model. So this idea that we have the Earth at the center, and then all of the other objects go around it on little spheres. We don't move, all of these things rotate. It turns out in order to get the motion of the planets right, you have to use something called epicycles, which we'll talk about in a minute. We now know, though, that the solar system looks like this. The sun is at the center, all of the planets orbit it. One of them is a little bit crooked, Pluto. The stars, very far away and don't really move. Now, I realize in saying this that I mentioned Pluto. I promised to tell you all something about Pluto last time. What did I promise to tell you about Pluto? Is Pluto a planet? Yes. So here's my answer to if Pluto is a planet. Let me tell you the history of Pluto. You can see Mercury, Venus, Mars, Jupiter, and Saturn with your eyes alone. But you can't see Uranus or Neptune. Those were discovered in the age of telescopes. And a little bit later, we also discovered Pluto, this other object in this tilted orbit. Now, Jupiter is enormous. Saturn is also very large. Uranus and Neptune are also large gas giant planets. But Pluto is a tiny little ball of ice, smaller than the moon. And that's kind of unusual. It's really tiny, right? But there it is. It's out there. We discovered another thing. And this was in the earlier part of the 20th century, I believe, with this tradition of naming the planets after Roman gods. Mercury is the fast god of carrying messages. Venus is the god of beauty. Mars is the god of war. Jupiter is the god of cheating on your wife. Saturn and Uranus are Titans, predecessors to the gods. Neptune is the god of the sea. And Pluto is the god of the underworld and of death. Porpoise points out that Pluto shares an orbit with other stuff, one called Charon. Charon is actually Pluto's moon. In Roman mythology, Charon is the boatman that carries you over the river Styx when you die. But yes, Pluto shares its orbit with other stuff, and that's important. So that's the history. And when I was in school, I learned, Pluto is the 9th planet. It's actually closer to us right now than Neptune, or it was when I was a young boy. But then we discovered there are many things like Pluto out there. And astronomers, in talking with other astronomers, need a technically precise definition of planet. Pluto is a special place in our history, right? It's named after one of the important Roman gods. It's part of our concept of what's in the solar system. It has a place in our hearts. But technically, if we make Pluto a planet, if we call Pluto a planet, we have to call dozens of other things out there, some of which are bigger than Pluto, planets as well. So the astronomers need a technically precise definition of what is a planet. But in the popular imagination, a planet is a thing that goes around the sun that has a special place in our hearts. Right? And both of those definitions have value. I'm not going to tell you that the astronomer's definition is the only one that matters, and that the popular definition doesn't matter. So let me tell you a metaphor. When you go to the doctor, and the doctor says, "Do you have any history of cancer in your family?" You're not going to say, "Well, my grandma didn't have cancer, and my grandpa didn't have cancer, and my mother doesn't have cancer, and my father didn't have cancer, but the family cat had a tumor." family dog had bone cancer. No one's going to say that when their doctor asks them if they have a family history of cancer. But when you go to the family reunion, has anybody been to a family reunion in the last couple years before COVID? We have any family reunion goers? Yeah. And what do you do at the end of a family reunion? Like, what's the last thing that always happens? You say goodbye, but before that, what do you do? You give each other hugs. Oh, I miss giving people hugs. I haven't seen my family in a long time. You take leftover food. Yes, you take food to go. Your family is cool. You take pictures. Yeah. So you get everybody together. That's what Twitch chat is saying. So you get everybody together, right? You get your grandma and your grandpa and all of your sisters and your brothers and your cousin and your aunt and your crazy uncle who has weird ideas about politics that you try not to argue with. You get all of these people together and you get them all together and you take a picture. Who else is in the picture? You also get the dog. When you're talking to your dog is not a member of your family. Because your doctor doesn't care if your dog had cancer. But when you're taking that picture with all of the people important to your family, you betcha the dog is in the picture. So that's my answer about Pluto. Is Pluto a planet? Is Pluto a trans-Neptunian object that's not a planet? Pluto is a dog. And that's what Pluto is. So that's the story that I tell every time I get asked that question. And I told it last section, and there was a student who has a dog named Pluto. And they said that they would send us pictures. So anybody who has cats and dogs, or snakes, or lizards, or fish, or octopi, or a pet rock that you would like featured in an astronomy problem, send me pictures of your pets, and they will show up in stuff we do for class. Or your ferret. Skunks are good, birds are good. Giant tarantulas are good. So there's my spiel on Pluto. Does an Xbox count as a pet? Everybody's talking about Xboxes today. Did something happen in the Xbox world that I don't know about? Dorothy, I bet you I have more photos of my cat than you do. There's a new Xbox coming out. The last console I had was a PS1 when I was an undergrad in like 2002, and since then I've been a PC person. Okay, didn't know this was happening at Xbox Land. Okay, so what I'd like to do, back to our story about astronomy, is I want to look at how this shift in perspective happened. How did we get from here, thinking that the Earth was at the center, to here, thinking that the sun is at the center? And how is this part of the birth story of science? And what else did we learn about the sky when we did it? Michael, I'm not sure what you're asking about mayonnaise. I imagine it's some meme that I'm not aware of, but mayonnaise is gross. And I'll fight you on that one. Mayonnaise is gross. Whipped cream is gross. Sour cream is gross. Grapefruit are tasty. All of these are laws of physics. It's from SpongeBob. Okay, I didn't watch SpongeBob. I see. Something has touched a nerve, and now Zoom chat has switched to all caps. All right. All right. So to tell this story, we have to go to the Greek civilization. And when I say Greek civilization, I mean a civilization that spanned from the islands that are what is now Greece, down through the eastern part of the Mediterranean to northern Egypt. We're going to talk about the city of Alexandria in Egypt. It was kind of a mixture of Greek traditions and Egyptian traditions. Henshi says, the first time I haven't agreed with you. Yes. RIP Library of Alexandria. Yes, exactly. And the Greeks saw philosophy as a very elevated pursuit. And there are a couple of properties of Greek philosophy that made it a very powerful way to get at the truth of nature. First thing is that they saw the behavior of nature as something we can understand, right? If you just throw up your hands and say nature is mysterious, you're not going to make any progress. But they said, we can understand this. We're pretty smart. They also proposed natural causes rather than supernatural causes for phenomena. Now, these things kind of went hand in hand. Greek mythology made claims about both. For instance, there's a Greek myth that says the reason we have winter is because Persephone, the goddess of growing things, was basically imprisoned by her abusive husband Pluto in the underworld, and she was very sad, and since she is the goddess of plants and growing things, all of the plants are sad too. That's the Greek mythology explanation for the seasons. So I guess Pluto is both a dog and an abusive husband. But Greek philosophers didn't just stick with this explanation. They looked at actual mechanical, natural causes of what's happening. They combined those natural causes into models. So like we have on the board, when we have been drawing little doodles of the Earth, the Sun, and the Moon to try to understand how the phases of the Moon work, that is connected directly to the Greek tradition of drawing models to understand stuff. Oh, Porpoise has corrected me on Greek mythology that it was actually Demeter, Persephone's mother, being sad she couldn't see Persephone. And that Persephone was cool being in the underworld. So let me just read what they said. It was Demeter being sad she couldn't see Persephone. A lot of theories say that Persephone was actually cool with being stuck with Pluto in the underworld. Being with Pluto in the underworld. So yeah, that's a more benevolent interpretation of that story. Demeter is the goddess of agriculture. Like, I can't see my daughter. She's with her husband here. It's now snowing. The Greeks also were very fond of mathematics. Math to them was geometry. They didn't have access to algebra because it hadn't been developed yet. But they were very experienced at geometry. And most importantly, they recognized that the models that they built, the little cartoon ways to imagine the workings of the universe, had to agree with what you really saw. Here's an example. So they realized that if you look at the moon during an eclipse, and you look at the moon during the period when an eclipse is elapsing, it looks like that. So what does that tell you? What would you conclude if you saw a partial lunar eclipse and saw that? Eight moons, yeah. So this is like a photograph at different times. With modern photography, we can do that. Yeah, we know that, so something's in the way. Mariam, what's in the way? Something's in the way of the sun, but what is in the way is the Earth. This is the shadow of the Earth. And that tells you, as Henshi has said in Twitch chat, that the Earth is a sphere. This was known a very long time ago. And not just to the Greeks. Other people figured this out too, but this is how they did it. But there were some properties of Greek thought that made it somewhat less conducive to understanding the solar system. As I said, they saw nature as something understandable. They built models to understand that, and these models were mathematical, by which I mean geometric. Remember, the Greeks are kind of obsessed with geometry. But they were a little too obsessed with geometry. Like, Pythagoras worshipped numbers, like really worshipped numbers. The Pythagorean theorem guy, he was a little bit weird. There was like a cult of numbers that Pythagoras ran. And they thought that things that are beautiful, like circles or symmetry in mathematics, were also had to be true. The more beautiful something was, the more true it had to be. So an example was, circles are the most perfect shape. So everything in the sky has got to be circles because the sky is perfect, perfection is beautiful, beauty is true, and so everything up there is circles. That's an example of Greek logic. It seems really weird to us, right? But this is an example of how many of this thought, how much of this thought progressed. And they also saw astronomy as different from natural philosophy. So natural philosophy is the branch of philosophy trying to understand nature, but the Greeks said, okay, what's the best way to understand nature? Well, clearly we should drink wine and think about it really hard. And maybe that's good in some ways, but at some point you ought to maybe devote a little bit more time to the dirty work of poking at nature rather than drinking wine. And the divide kind of goes like this. So the natural philosophers, people like Aristotle, were very concerned with what is true with the capital T. They were really concerned with logic. And in realms of philosophy that could be attacked by pure thought, by just sitting around and drinking wine and thinking, they made great progress. But they saw the detailed workings of the stuff up there as kind of not their job. And they saw figuring out, like, where is Venus going to be tomorrow? Like, is it here or is it over there? That is kind of grunt work as beneath their station. So Scarlett in Twitch chat says, I do that too, presumably drinking wine and thinking about things. Does that make you a Greek thinker? Well, I don't know if you have any Greek origin or not, but that is certainly heir to that tradition, right? The tradition of intellectual discourse, of talking to people about what is true and having like geeky conversations basically over wine or food or whatever, and having that be fun, that tradition goes back at least to Greek civilization, continues to like the French salons and so on, and to the present day. So, Scarlett, when you say, does that make you a Greek thinker, it makes you an heir to that tradition, yes. And that's the great thing about human society, right? We all share in this cultural heritage. And Scarlett points out that they are Arabic, close enough. We actually will come to the Arabian world in our story in just a moment. The Greek astronomers, on the other hand, rather than being people concerned with truth with a capital T, they were concerned with how can I figure out where Venus is going to be? Is it going to be here or there? They weren't so concerned with what is true. They were concerned with, do we get the right answer? And we know Greek astronomy mostly from a book written by Claudius Ptolemy known as the Almagest. Before I talk about that, let's look at what the Greeks knew. So they knew all the stuff we've learned already. They also understood parallax, which is the subject of this week's lab. They knew, for instance, that if the Earth moves, so here's a cartoon of the Earth going around the sun, and if the Earth moves from point 1 to point 2, then a nearby star, this one, is going to line up with different spots in the background. Right? So if Earth is at number 1, this star will line up with star B. But if Earth is at number 2, then it will line up with star A. So if the Earth moves, then we ought to see the perspective of the stars change. If you want to test this for yourself, get your finger, hold it out at arm's length, and then open and close your eyes one at a time. And you'll see the position of your finger relative to the background shift back and forth. That's parallax. And you could either use your 2 eyes for it, or you could move where you are. And if Earth moves, they thought we should see parallax in the stars. But we don't. Now, it turns out there really is parallax in the stars, but they're so far away that it's not very large. And you'll talk about that in this week's lab. But they didn't know that. They thought, no parallax in the stars, Earth must not move. They also knew something called the retrograde motion of the planets, which we've discussed before. So here's a picture of the motion of Mercury over about 2/3 of a year. So you may not be able to read the dates here, but this is basically in December. And we see that from December to August of the next year, Mercury moves forwards relative to the stars. Notice Virgo is labeled here. Then stops and turns around, moving in retrograde, and then turns back around again and moves in prograde. They knew that happened, and that was the really hard thing to understand. And that's what Ptolemy managed to do. He lived in Egypt, in Alexandria, as people have mentioned in Zoom chat. And this was one of those magical places in human history where cultures have come together. You might know that the name Claudius is very Roman, actually. But the name Ptolemy is Egyptian. It's a name, he was not a pharaoh, but it is a name that many pharaohs had. So he was a person who spoke Greek, but who lived in Egypt in this kind of nexus of civilizations. And he was not a natural philosopher, the sitting around and drinking wine type. He was a go out and look at the stars type. He was an astronomer. And we know him from this book, The Almagest. Now, you're probably saying that doesn't sound Greek, and it doesn't sound Latin, it doesn't sound Egyptian. That word is Arabic. And many of our words used in astronomy and in science come from Arabic, as do our numbers. The particle al, A-L, in Almagest, means the in Arabic. So the stars Algol and Aldebaran, those names are Arabic. Algebra and algorithm are Arabic words for mathematical ideas. So when Scarlett in Twitch chat says that they are Arabic, that is another tradition that our stuff today, our understanding of science is descended from. Like a science language course. It's interesting, right? Because when I was a student, anyone studying mathematics, to get a mathematics degree, you had to study either German, Latin, Russian, or French. Because so much mathematical literature is written in one of those languages. And they wanted people to be able to read these things in their original languages. Einstein didn't write in English. Einstein wrote in German, right? So I think you can almost trace many things in culture, in science, and anything by looking at the words. And the fact that we have so many words for things that are Arabic tells us something about Arabic contributions, particularly to mathematics in this story. So this model we talked about, Ptolemy is the one who introduced it. So the idea is that everything in the solar system is connected to these little crystal spheres that spin around Earth. And they go in a uniform, perfect way. Now, the going from the inside out, I'm going to click this so you can see my mouse cursor. So here's Earth. Luna is the moon. Mercury, Veneris, Venus. Solis, the sun. Martis, Mars, Jovis, Jupiter, Saturni. The Octavium Firmamentum with all of the constellations of the zodiac labeled. And then on the outside, Decimum Cellum Primum Mobile, which is a later idea added of the prime mover connected to religion. We're getting kind of more and more spiritual as we move out. And on the outside, Cellum Imperium Habitaculum Dei et Omnium Electorum, the Empyrean heavens and the house of God and all of the saints. So that's a very Christian idea, right? This is a picture from medieval Christians who have taken Ptolemy's model and worked it into their own theological concept of the world. So that's what Ptolemy thought. Here we are in the middle, and everything spins around it. Oops, that's not the button I want to click. That's the button I want to click. Well, kinda. Earth isn't quite at the middle, and the circles don't turn quite uniformly. And this I find really interesting, right? Here is a medieval picture of the world, but it leaves out the things that Ptolemy had to do, the really hard things Ptolemy had to do to get the right answers. Because if the spheres just turn around the Earth, that doesn't predict retrograde motion. Remember, everything's got to be circles, right? Because circles are perfect, and perfection is beautiful, and beauty is truth. That's how it went. So what Ptolemy said is, all right, here's the Earth, but it's not really at the center. And here's, say, Mars, or Mercury, but it doesn't just travel in a circle along its orbit. Right? Instead, it goes in a loop-the-loop. This little circle spins, and it moves around this big circle, which also spins. Yes, Porpoise, this is like a toy called a spirograph that I had as a kid, and you did too, a little thing you could doodle with and make those patterns. I remember playing with one as a boy, and that's part of how I got into geometry. Thanks, Mom. So these little loop-the-loops are called epicycles, and if you're confused by this, so am I. So let's watch this in action. So I'm fading over to YouTube here. No, I don't want cable-free live TV. Go away. So basically, they thought that the planets moved like this, and that explained retrograde motion. That if you look at the dot, sometimes it's going forwards, and sometimes it appears to be going backwards. And yes, Benjamin in Twitch chat is kind of memeing and saying, hey, Ptolemy, our model of perfect circles doesn't really work. What should we do? More circles. Yeah, that's basically what they did. And it was really complicated, right? A huge number of moving pieces. Circles on top of circles, different centers, different fudges for every planet. But it worked. If you did all of it, if you thought about all the little circles, and remember the Greeks were pretty good at geometry, you could predict with amazing precision where all the planets would be, even if you needed dozens of little epicycles to get it right. So I'd like to ask you all, in Twitch chat and in Zoom chat, tell me what you think about this. How we ought to evaluate Ptolemy's model. And I've given you some multiple choice options here, but you can also type your own. How do we think about Ptolemy's model? Erica says, I don't even know. Alex says, just because it adds up doesn't mean it's right. There are no correct right or wrong answers here, right? I want to know what you all think. Pamela says B, so some things are really complicated. If this gives us the right answer, maybe it's true. LMCG has said C. This idea of truth is overrated. Maybe if it gives us the right answer, it's right. A couple of folks have said D in Twitch chat. B or D. Give you all a moment to type your thoughts out. Jacob has said D. Orange Shirt Guy has said C. I think all of these have merit. Arian, the question is, what do you think about Ptolemy's model? How should we evaluate this epicyclical, things go in loop-the-loops description of the solar system? You could argue that the universe ought not to be that complicated, right? And it turns out now that we've made so much progress in understanding the universe, it turns out that the laws of nature are honestly pretty simple. But some things are complicated. Magnetism, it turns out, like making a magnet out of iron is really, really complicated. How that works, you cannot write down simple equations that tell you how iron turns into a magnet. Some people have said that, wait a minute, we ought to judge things by whether they get the right answer or not. Porpoise in Twitch chat has pointed out that the loop-the-loop things happens if you compare two planets' orbits around the sun. So what you mean is if you look at the difference between where Earth is and where Mercury is, you see that. Yeah, you do. I'll show you that next time. Other people have said D, and D, I think, is the closest to the modern scientific perspective, which is there is some underlying truth of nature. There is a way nature works. We can know what it is. And if we figure out how nature actually works, a true model could predict other stuff. So we'll see in a moment a model that does predict something beyond. Or you could maybe just say that epicycles are alternative facts. So now we continue our story into the future. Remember, we're at about 100 Common Era right now. As someone alluded to earlier, the library at Alexandria was burned. Pretty much everybody blames somebody else for doing that. And Alexandria kind of declined as this center of learning in the world. And that center of gravity in the Western world moved east. Moved from Alexandria to the Arab world. The Arabs watched the sky, like everyone else did. They looked at Ptolemy's model. They realized that while Ptolemy had a lot of brilliance, he made some mistakes in his mathematics, and they fixed them. Remember, we use the Arabic numerals. Our numbers come from the Arab world. So doing calculations with numbers and doing them precisely without making mistakes is something that the Arab tradition is very good at it, right? So they fixed a lot of these issues. Catching up in Twitch chat. Henshi says something interesting. Henshi says, sure, the model might work, but there is information missing. Error will pile upon error, and in a little bit, we won't understand anything. That's an interesting point. What mistakes are there in Ptolemy's model? Because we know that's really not how the solar system works. It makes accurate predictions of the motions of the planets, but is there anything it doesn't predict? Are there any predictions it gets wrong? That's what you're saying, right, Henshi? We will see one of those in a little bit. So now I want to move forward another few hundred years to Europe. we're going to look at Europe in the 1500s in a moment, but before that, before the Renaissance, Europe didn't really have that much of a tradition of doing natural philosophy. Europeans are mostly concerned with theology, with the nature of the divine in their philosophy. So they knew about Ptolemy's model, but it was mostly just applied to figure where the planets would be rather than thought about. As Porpoise points out, even if epicycles aren't physically accurate, they could still be used to predict what we would see. So the Europeans were thinking about things like how many angels can dance on the head of a pin, and what is the nature of the Trinity, and things like that. Meanwhile, Ptolemy's model still works with the corrections made by the Arabs. It worked brilliantly. It was off by a few degrees in 1,000 years, which is just stunningly accurate. But all of the epicycles started to feel too complicated. And a Polish-German fellow by the name of Copernicus then got a new idea, who said, maybe everything orbits the sun in circles. Maybe the sun's at the middle rather than the Earth. And then you don't need epicycles, right? Then, as people have said, the relative motion of Earth and Mercury together would give us the retrograde motion of Mercury, rather than just Mercury having to do it all itself by going in funny patterns. And this gets you retrograde motion without epicycles. New idea. Here's a picture of it. So we again have all the orbits labeled. Here's Sun at the center, marked Sol. I can't read that word, but this is Mercury. So many days around, I think, tells you how long it takes all of these orbits to happen. Venus in 9 months. Earth and the orb of the moon go around in a year, revolve in a year in Latin. I don't know this word. Mars, in some amount of time that I don't know, revolves. Jovis, Jupiter, in 12 years revolves. Saturn, in 30 years revolves. And outside the sphere, the immobile sphere of the fixed stars. Porpoise. So LXXX, so 80 days, I guess, for Mercury. I don't know that word in Latin. Someone who speaks Latin better than me could help me out. So this is basically our picture of the solar system. And there's a really funny foreword, a preface added to the book, not written by Copernicus, but written by his publisher, who said, this is weird, this is unusual, but it's just mathematics. And we ought to judge it on whether it makes accurate predictions rather than whether its philosophical content is true. And to us, that's really weird, right? We would say, well, if it doesn't make accurate predictions, it's not true. But accuracy was not really a core part of truth. Beauty was what determined truth, in a sense, which is very different than our modern perspective. But this is, in a way, why Copernicus's writing didn't provoke a big fight. So how do we evaluate Copernican heliocentrism? How do we judge it? How do we evaluate its place in history? So tell me in Twitch or Zoom chat, type your thoughts on this. Should we ask whether it is simpler than Ptolemy's model? Should we ask whether it is more elegant, more beautiful? Should we ask whether it predicts things precisely, whether it gets the position of Mars right? I mean, Ptolemy's model is very, very accurate. Do we ask it to predict something new? Do we look at whether it inspired people? Or some combination or some other standard? And Luke says, well, got heliocentrism right. And LMCG and Porpoise are asking about whether it fits observations and data. Okay? Precision of prediction. Does anybody have another comment on how we ought to look at Copernicus's work? And Marvelum says whether it inspired people to get closer to truth. Again, the progress of human civilization, the progress of human society and knowledge has been upward in the thousands of years of our history, but it hasn't been always upward and it hasn't always been in a straight line. So maybe Copernicus made advances in some ways, but not in others. And it turns out the reality is an oops. Porpoise, I'm going to cite your quote in a bit. I want you to keep that in mind for Thursday. Porpoise has said, breaking the willingness to say, close enough. So Porpoise has written in Twitch chat, ask whether it fits more of the observations and data than Ptolemy's. It's important to break the willingness to say, this is close enough. We're going to talk about that in a lot of detail Thursday. So I want you to keep that thought in mind and come back to it next time. Turns out Copernicus's model was kind of crappy at predicting where the planets would be. It got retrograde motion right, but it didn't actually tell you where they would be. It got the motion not all that accurate. And you could add epicycles and that would help, but they didn't even help that much. And then you're back to all of the complexity of Ptolemy's model. Now I want to move to another sort of observation. So Copernicus lived, look at the dates up at the top, around 1500. Porpoise asks, did he have the orbit lengths horribly wrong? It turns out it wasn't the orbit lengths, it was another feature of the orbit. And what that feature is next time. Galileo took advantage of some work done in optics. Galileo had this radical new idea that the best way to seek truth is to go measure stuff. To go measure lots of stuff as well as you can and to devote a lot of time to making better measurements. And what he did, as it relates to astronomy, is got a hold of a telescope. It turns out that I am nearsighted, and you use glasses like this that are concave to correct nearsightedness. But if you're old, then you have trouble focusing close, and you use convex lenses to correct old age eyeball, called presbyopia. And in the Netherlands, just a few years before, people figured out that if you took an old age eyeball fixer and a nearsightedness eyeball fixer, the two kinds of glasses, and put them on opposite ends of a tube, you could make a telescope. Lets you see things very far away. And of course, the Dutch were very excited about this for use at sea. But Galileo got a hold of one and said, I can use it to look at the sky. He made some improvements to the optics, pointed it at Jupiter, and saw this. This is a video shot from a NASA spacecraft named Juno. There's a voiceover here, which I'm not playing. So here we're looking at Jupiter. It's just a planet that wanders back and forth on the stars. But Galileo looked at it through a telescope and saw what you're about to see. Now this is real time-lapse footage shot from the NASA spacecraft Juno on its way to Jupiter. What do you see? Yeah, moons. There are things going around Jupiter. The mythology is kind of funny. When we discovered Jupiter's moons, Jupiter, also known as Zeus, was the god of marital infidelity, and the moons are named after other people that Jupiter slept with. The spacecraft is named Juno, which is the name of Jupiter's wife. So NASA, with a great sense of humor, sent Jupiter's wife to go check on him and his mistresses. And Galileo saw this. This is not in real time. This is a time lapse. They take hours or days to go around. But this was shot not too long ago. Now you'll notice that Jupiter is only half full. Why is that? Well, it's got phases just like the moon does. The sun is off here to the right side of the frame. We'll speed this up a bit. So here they go around. Oh, and now we have an ad for the NASA spacecraft. So going back to our slides. So Galileo saw that with his telescope. And this was a big shakeup. Galileo said, wait a minute. If there are things orbiting Jupiter, then not everything orbits the Earth, right? We're not at the center because, look, there's another thing over there that's clearly at the center of other things moving. And this was a big deal. This was a big shakeup to both philosophy and to religion. I want to rewind a bit to the very beginning of the slides and present you two quotes from Galileo. I'll do the top one first. People have often talked about Galileo's conflict with the Catholic Church, but Galileo was a religious person himself. He wrote, "Nature is inexorable and immutable. She never transgresses the laws imposed upon her or cares a whit whether her abstruse reasons and methods of operation are understandable to humans. In modern words, nature gonna nature. For that reason, it appears that nothing physical which sense experience sets before our eyes, meaning what we see, or which necessary demonstrations prove to us, in other words, the experiments we do, ought to be called in question, much less condemned upon the testimony of biblical passages which may have some different meaning beneath their words. For the Bible is not chained in every expression to conditions as strict as those which govern all physical effects, nor is God any less excellently revealed in nature's actions than in the sacred statements of the Bible." What Galileo is saying here is, so Galileo was Christian. He said, okay, if God made all of this, then clearly nothing that exists around us can be against religion. Because if God made all of these things are the way they are, they're part of creation too. Galileo is also here elevating the things we see. He says, things sense experience before our eyes, or which demonstrations prove to us, all of these things are clearly real, and thus they cannot be in conflict with religious ideas. Elena brings up a really good point. Did nobody believe Copernicus? It turns out, not really. Because, remember the foreword in Copernicus's book that says, I don't claim these things are true. It was written by his publisher. These things aren't true, they're just math. And you should judge my math based on whether it makes accurate predictions. And of course it didn't. So Copernicus, we know, was right about what's at the center of the solar system 100 years before Galileo. But he didn't argue this was true in a philosophical sense. He just said, here's a model. Or rather, his publisher put that in. It's a really good point, Elena. Why was this not a bigger deal? And it turns out it was for some people, but it didn't really make a splash. But Galileo did make a splash. You can see this here as well. So this is a picture that I took from my parking lot up in Liverpool where I live, in my apartment complex, taken with an ordinary camera and an ordinary lens that I use to photograph birds with most of the time. I didn't see the moons, and I got the picture and I took it inside and I said, oh, there they are. And it turns out that I put the time into Stellarium, and there you go. Stellarium thinks the moons are exactly where they were. And that's astounding, right? That somehow my little laptop, this little thing right here can, with a little Dell refurbished sticker on the bottom, can do mathematics so precisely to tell me where Jupiter's moons are going to be. How did we, and that's really the story of this class, how did we get here, right? How are we able to do this? And last weekend, a couple of days ago on Saturday, I went down to Labrador Hollow and I took this picture. It's a little bit blurry because I was shooting over water, and the mixing of cold and warm air over water refracts light. I put that time into Stellarium, and there they are. So clearly they move, right? I want to go out all night and take one picture every 5 minutes as Jupiter goes over the sky and make a movie out of them. But I slept last night rather than doing that. So Galileo published these things that he saw with his telescope, and he said he also saw that Venus has phases. I'm not going to go into all of the reasons why, but it turns out that you can only see phases of Venus if the sun is at the center of the solar system. So since the sun is at the center, or since Venus has phases, Galileo argued the sun must be at the center, and Copernicus was right. So now he's not just predicting things, now he's making real claims about how the world is. And something else happened. Martin Luther advocated for reform in the Catholic Church, and he ticked off some powerful people, began the Protestant Reformation, and then the Romans responded with the Counter-Reformation and the Inquisition. So they had gotten a bit touchy about heresy. They said, Galileo, you're a heretic. All of your books are banned. Galileo didn't care. He published a book in 1632 that was a dialogue between a person arguing the sun is at the center, who looks smart, and a person arguing the earth is at the center, looking stupid. And the Inquisition said, oh no, you don't. And they arrested him and they put him on trial. They declared him a heretic, they banned all of his books, and they sentenced him to house arrest. And there's a story that when he was being marched out of his trial at the Inquisition, he muttered under his breath, but still it moves. No matter what you say, the earth still moves. Benjamin says, wasn't that book roasting the Pope? I don't think it was so much roasting the Pope, although I could be wrong. It was more roasting the geocentrists, and the Pope happened to be one. So they marched him out and put him under house arrest for the rest of his life. And yet it moves. I dissent. But, of course, Galileo was right, and the church unbanned his books, unbanned heliocentrism, and presumably fished him out of hell in 1835, 200 years later. Galileo did not see, again, a conflict between science and religion. That he's not some kind of anti-religious crusader. He's just saying, here, I've got a telescope. Look, you look too, is all he did. So that's all I've got for today. I'm going to continue our story later. So after this, what I want to do is, where are we now? Galileo has indisputable evidence that the sun is at the center of the solar system. But yet, if you take Copernicus's model of the solar system, it doesn't predict how the planets move. We have to reconcile those things, and that's what we will do on Thursday. So thank you all so much. I really appreciate your time and attention. I know everybody is sick of Zoom. We all are so tired of sitting in front of computers. And I really appreciate that you all are here and asking questions and making comments and typing stuff. Please feel free to just type stuff to me constantly during class. I really appreciate your time. I really appreciate your attention and enthusiasm. I'm going to go get a bagel, and I'm going to go right out to the steps of Hendricks Chapel, where I will be from no later than 4 until 5:30. I might be able to stay a bit after 5:30 if there are people there, but I'm going to go talk to folks. Thank you, Gigi Uzda. I don't know how to pronounce your Twitch handle. I'm glad you enjoyed today's class. Thank you. Thank you for coming. I'm going to stay here for another maybe 5 or 10 minutes and take any other questions or talk to folks. Yes, Henshi, I will very much enjoy that bagel. For those who don't know, there is a place where you can buy bagels and tea underneath Hendricks Chapel called People's Place. It is full of memes and tasty things. Yes, Maeve, you can connect to this same Zoom room and talk to me. So I'm going to stop the recording here.